Hi, I'm Paula Hollywood with the ARC Advisory Group. We're here today with Paul Casto, Intelligent Asset Practice Leader at GrayMatter Systems. Thank you for being with us, Paul.
Thank you for having me, Paula.
Paul, there's a lot of solutions being offered in the marketplace for asset performance management, and I'm finding that people call it different things. There seems to be no consistency. From your perspective, what is asset performance management, and what are the solutions that make up a robust asset performance management program?
That's a great question because over the last couple of years, there's been a lot of discussion around APM and the definition has really changed. Back in the day, when I was working with Bonds Hart, sort of the father of asset performance management, it was really a holistic solution. That solution included a lot of things that we knew about from years gone by. Preventive maintenance, predictive maintenance, surveillance technologies. And then, of course, as time progressed, it came to include asset health, taking data to look at the health of your assets. And then today, really includes those prognostic solutions. Machine learning is very popular today. So it is I always describe it as an umbrella of solutions. APM includes all of those things, from preventive maintenance to surveillance technologies to machine learning. It's a holistic solution. And it's a holistic solution because different failures have different failure characteristics, and there's not one size suits all. So in the marketplace today, we see a lot of people talking about APM, and what they're often selling is a portion of APM, a slice of that holistic solution. But if you think about APM in general, it's really focused on equipment. It's focused on equipment reliability, all the things we can do to reduce the risk of equipment failure. And in the end, we want to raise availability and we want to lower overall operating cost. So think about APM as a holistic solution with many different tools under that APM umbrella.
You mentioned machine learning, Paul, and I've noticed at this forum that's a very popular topic. But I don't see it as the be-all to end-all. But could you elaborate on when it's appropriate, when it's not appropriate, and what are the benefits of it?
Well, sure. Well, machine learning is the hot topic this year. 3 years ago, it was edge computing, and then it was everything's going to be in the cloud, and now it's machine learning. And machine learning is a very powerful tool. And it has a couple of applications in our business, especially if you think about the process side of our business and applying machine learning to material flow problems, to really what I would call production problems. It is an extremely powerful tool with numerous applications in that area. Over on our side of maintenance reliability and APM, it has a lot of applications there as well. If we have good failure data on critical equipment, our ability to take that data, to ingest it, to analyze it, to look for matching patterns or different things like that for critical failures is very powerful. But there are some drawbacks to that because, especially in an existing plant, all of that equipment may not be instrumented. So if we need the proper data from those pieces of equipment to be able to do machine learning, it could cost us a lot of money to go back and instrument that data. If we're putting new equipment in, then during the design phase, we would properly instrument the equipment so that after we start it up, we could do some of those kind of things. Also, different failures have different characteristics. Failure modes have different time frames, and how failures occur are different. So every failure mode out there, which is what we're really focusing on through APM, is not conducive to machine learning. For example, you may have a pump. You may instrument that pump and do a lot of things with it, and yet you have a failure mode around a seal leak. The best way to find a seal leak still is have somebody walk by on a regular basis and notice that that seal's starting to leak. So once again, machine learning is a really powerful tool, but it's just one tool in the umbrella of APM.
Okay, but the way you've described it, it sounds like a tool that would help bridge that divide between operations and maintenance and for the betterment of the organization, for better performance overall.
It is. It really is a powerful tool. And think about sort of the continuum of where we've been over the years. Years ago it was break fix, and then we had monumental changes when we started doing time-based maintenance. A cycle-based maintenance, time-based maintenance, condition-based maintenance, and that spectrum has moved to predictive, to surveillance technologies, to asset health, to prognostics, and as technology continues to change, the overall solution set for APM continues to grow.
Okay. Most manufacturers are realizing that the importance of integration of disparate sources. Our research still shows us that integration is one of the challenges, the greatest challenges of manufacturers. What data can APM integrate with a special focus on MES and operations, CMMS and maintenance?
Well, remember, if we think about APM, it's all about equipment reliability, and availability of that equipment. So we want to gather up all pertinent data that has to do with equipment reliability and availability. So there are lots of different sources of that data. It may come from historian. It can come from the CMMS system. It can come from, I have an RCA system running in a different database over there, but I want to capture that information. I've been doing my failure mode analysis in an access database. APM really needs to bring all of that data together. We want to get those disparate sources of information. We want to bring them together and think about APM as your source to come and have a single view of all that data. So when you're designing an APM system, one of the exercises we go through is to look at all those disparate sources of data with a mindset of what data could we use for better reliability? What data can we integrate? What data should we bring into the APM database? What data should we just interface to? Does that interface need to be a one-way or a two-way interface to really leverage all of that data? So just to sort of summarize that question, when we think about APM, it's all of those sources of data that can give us insights to the health of that equipment. You might think about going to a whiteboard and drawing a circle and writing APM or your ideal reliability information depository, and then start labeling and drawing other circles about all of the other disparate sources of information that we have out there. But to be effective and to use all the tools under that umbrella, we need to identify those and either assimilate those or figure out how to interface, to those data sources.
Yeah, we can't, in this IoT age, islands of information and stranded data is of no value to anyone.
That's correct.
We all know the biggest nemesis for customers is unplanned downtime. How does APM help companies avoid unplanned downtime, become predictive, and lower overall costs?
Well, APM really is a lot about risk management. Sometimes we lose sight of what APM really is doing. And as reliability folks or reliability engineers, we're in the risk management business. Typically, we're focusing on physical assets out there, pieces of equipment. And what we're trying to do is to reduce the risk of those failures occurring. So by bringing together all of the tools in the APM tool set, we can look at particular failure modes associated with a piece of equipment. This is hard work. And it's one of the reasons many people want to jump to machine learning. So we can skip this phase of the basics. We need to understand those failure modes. We need to understand what the risk mitigation steps are for each one of those failure modes. And then we need to put a system in place to build that strategy and then interface to the maintenance management system. In the end, it's about those work processes we have over there in maintenance. We're going to plan our work, schedule our work, execute the work, and then improve the work. And there are many CMMS systems out there that are great at doing that. When we think about APM, it's about what work should we be doing over there. And it's especially about the old IPF curve. Remember the installation and the curve runs and you have a potential failure and then eventually you have a failure. Where we're focused today is in the IP portion of that curve, where things seem to be running smoothly out there. And what we're trying to find are those leading indicators of failure modes, or even what the conditions are right for the degradation mechanisms that lead to that failure. We want to identify those as early in the process as we can. And then we want to be able to communicate with the maintenance work management system so we can send alerts, we can write work orders, we can get all of those things in place so that we can proactively address these degradations before the equipment is seriously damaged. And by doing that, we extend the life of that equipment and raise availability, lower all of overall cost because we're being proactive, and we reduce the risk of those unexpected failures, the ones that bite us, that cost us a lot of money with all of that unplanned downtime.
Well, I heard you mention risk in there, and I will say that what concerns me is that's getting lost, I think, in a lot of the APM definitions that are out there. But I believe it truly belongs, and I'm very happy to hear you include that.
Yes, it's really all about risk management. It's how do we manage the risk of those failures? And when we think about risk is, the probability of failure times the consequence of those failures. And APM should look at both of those elements. It's can we reduce the probability of these failures? But we also should look on the consequence side if there are ways to reduce the consequence when a failure occurs. So that's what reliability is about. It's reducing the risk of those failures.
Thank you, Paul. We've been speaking today with Paul Casto of GrayMatter Systems. Thank you, Paul.
Thank you for having me, Paula.